Good morning to one and all. Now, in the second lecture, we have discussed what is prestress concrete, concept, history, comparison, and the applications. I am Dr. Subhash Patankar, presently working as a professor in Department of Civil Engineering, Sanjeevani College of Engineering, Kopargaon. In the first lecture, we have discussed the overall syllabus. In Structural Design and Drawing 3, the syllabus is divided into three parts. First part is related with the prestress, second part is related with the RCC, of course advanced RCC, and third part is related with the dynamics. So we have start the first unit, first part, or we can say that the brief history of the prestressing, that is under the unit number 1. Now prestress concrete, how to develop, we have discussed in this lecture. So here it is observed that the development of building material, in the first part, if you consider the material which resists the compression, in the past we have used the stone as well as bricks, later on we have used the bricks, and then there is a transition in this material, then we can use the concrete. Of course it is a plain concrete. Then some innovation is done in the concrete and we get the high strength concrete. Similarly, we use the second material, that is the material resisting tension. Now under this we use the bamboo, then we use the rope. Later on we can use the steel bars or steel wires. Then after that today we use the high strength steel also. So this is the invention, or we can say that the development in the material which sustain the tension. This is related with the material which take the compression. Then third material is also there which take both compression as well as tension, and under this category we can use the timber. Then later on we can use the structural steel, that means the channel section, angle section, eye section, like that. Then this is the total overall material which is used. Then when we combine this concrete, plain concrete, with the steel bars, reinforcement, called as the reinforcement, these two material we get the reinforced cement concrete. This is the transformation in the concrete. Then later on, of course, when we use the reinforced concrete, we cannot convert the concrete into elastic material. We have used the two different material, one is strong in compression, another is strong in tension, but we cannot convert the concrete into elastic material, and that's why we can use the high strength concrete and the high strength steel. It may be called as the tendon, and due to combination of these two we get the prestressed concrete. In this case we can achieve, or we can convert the concrete into elastic material. This is the beauty of the prestressed concrete. So, introduction, when we discuss the history of the prestressed concrete, we can say that the beginning with the plain concrete. Plain concrete is definitely strong in compression while weak in tension. Only 10 to 15% of the compressive stress will be treated as a tensile stresses. So it is weak in tension. It is good for most concrete, that is for the compression, but weak for the bending member or tension member. So strengthening the section in tension, steel rods are embedded in concrete to take tensile stresses, called as the reinforced cement concrete. In RCC, it is assumed that concrete take all the compressive stresses while steel reinforcement take tensile stresses. That means due to introduction of the steel, concrete is not converted into the elastic material. Now, third material, that is prestress. What is prestress? A concrete in which internal stresses of suitable magnitude and distribution are introduced so that the stresses resulting from the external loads are counteracted to a desired degree. Then it is called as the prestressed concrete. That means application of the stress before application of load. That's why it is called as the prestress. In case of RCC, it is assumed that no stress develop before application of the live load, or we can say that the external load. It is a method of applying pre-compression to control the stresses resulting due to the external load. Prestress is introduced by stretching steel wires or tendon and anchor them against the concrete. Pre-compression resulting either no tension or compression. So, this is related with the prestressed concrete. For example, we can say that this is the barrel, wooden barrel, which is covered, or this is the vertical strips of the timber or wood, and these are the metal bands. And when we put the grains, food grains, what happen? This will be counterbalance. This is the simple concept of prestressing. This is the example, old example. Second one, we can use the spoke of cycle, or we can say the two-wheeler or cart. Here it is observed that pretension of the spoke in a bike wheel is applied to such an extent that there will always be a residual tension in the spoke, and that's why it is not easily bent. That's why this is the simple concept of the prestressing in the olden day. Prestress is usually imparted to a concrete member by highly tension steel reinforcement like wire, strand or bar. The high strength prestressing steel is tensioned using hydraulic jack. The tensioning operation may occur before or after the concrete is cast. If the prestressing is done before casting, then it is called as pretension, and if it is done after concreting and after suitable period of curing, then it is called as the post tension. Now, reinforced concrete combine concrete and steel bars by simply putting them together and letting them act together as they may wish. That is the passive combination. But prestressed concrete combine high strength concrete with high strength steel in an active manner by tensioning the steel and holding it against concrete, thus putting the concrete into compression. Prestressing concrete is an ideal combination of two modern high strength material. Prestressing means initial creation of permanent trusses in the structure or assembly for the purpose of improving its behavior and strength under various service conditions. Now, this is the post tensioning. In post tensioning, concrete is there. There is a duct before casting the concrete element. There is a duct, and in the duct we can place the tendon or wire. After casting, after desired curing period, then this wire is stretched, and due to stretching the wire, this section is converted into compressive trusses. This is the post tensioning. In pre tensioning, we can stretch the wire, then put the concrete, then after desired period of the desired strength, cut this wire from both the end. This tension is converted into compressive trusses to the concrete. This is the pre-tensioning method. These two methods are elaborated in the next slide. Here, stages in the pre-tensioning. First, stretching the wire with the help of these two abutments and anchor, or with the help of jack. This will be stretched to desired degree. Then this is the mold. This mold, pour the concrete. Then after casting, after desired curing period, this will be cut, and due to cutting of this steel wire, what happens? Whatever the tensile stresses in the steel, it will be converted to the compressive stresses in the concrete, and that's why it will be bulge like this. And when external load will be applied, the beam bend like this, and that's why this will be counteracted or counterbalance. Now, when we consider the RCC, in RCC what happens? This is the beam. When load is applied, the beam bend, and due to bending, compressive stresses are developed at the top and tensile stresses are developed at the bottom. As concrete is weak in tension, that's why steel bar is embedded in the bottom side, and that's why we can say that this steel sustains the tension, and compressive stresses above the concrete will take concrete will take the compressive stresses. This is the simple concept of the RCC. Now in prestressing, we can stretch this wire, and due to tensioning this there are the two plates, and because of this, whatever the tension develop in bar, it will be converted to the compressive stresses in the concrete, and that's why it will be budge like this. And due to application of the load, what happens, this load and the bending due to the prestressing wire or tendon, it will be counterbalance. This is the simple concept of the prestress concrete or prestressing. Now assumption will be discussed during the design. Now this is the concept of pretensioning, as we have discussed already. Tendon is there, then mold is there, then pour the concrete, and after that, after desired period of curing, this will be cut, and that's why it develops the compressive trusses. This is the concept of post tensioning. In post tensioning, there is a cable or wire, or we can say that tendon in the duct. Concrete is casted, and after casting, this wire will be stretched. This is the first, no load, no tension. Second, with load, load is there, dead load is there, but wire is not tension, and that's why it is in no tension. Third one, load is not there, that means live load is not there, but we can stretch the bar, that's wire, that's why prestressing is there. And in the last case, external load is there and wire is also pressed, and that's why it is counterbalance. This is the post tensioning system. Now if you see the history of the prestressed concrete, in beginning with the 1886, P.H. Jackson from the San Francisco taken patent for the construction of artificial stone, or we can say that the concrete, and the concrete pavement for tensioning the reinforcing rod set in sleeves. Then in 1888, Dorling, then Mandel in 1896 have done take the patent. Then 1907, Cocaine from Germany, loss of prestressing due to elastic shortening of concrete will be discussed, was discussed. In 1908, Steiner. In 1923, Imperger from Venia, methods of making wire bundle reinforced concrete pipes by binding high tensile steel wires on pipe at trusses ranging from 160 to 800 MPa. This is the progress. In 1925, then Dill is there. Then 1928, Dischanger use of unbonded tendons demonstrate in the construction of major bridges of the deep girder type, but actual work done in the prestressing in 1928 by Prestressed. He demonstrated necessity of using high strength wire or high strength steel and concrete to account various losses of prestressing due to creep and shrinkage. And this is the real work start in the prestressing or prestressed concrete. In 1931, Hoyer gives the system, that is the pre-tensioning system. Then again Prestressed in 1939 gives the conical wedge for the end anchorage vibration technique for the production of the high strength concrete. The invention of the double acting jack for strengthening or trussing high strength steel wires. This is the real work done by the Prestressed. Then Magnell also developed the Magnell system within two wires were stretched at a time and anchor with a simple metal wedge at the end. This is the in 1954, Prestressed Concrete Institute is formed. In 1957, World Conference on Prestressed Concrete in San Francisco. In 1960, Prestressed Concrete Building Codes was developed. Then similarly in the same year 1960, the use of prestressed concrete bridge has become a standard practice in the US, span 18 to 36 meter. In 1970, post tension bridges of medium span, that is span is increases after 10 years. This is 18 to 36, here 45 to 200 meter in the form of continuous or cantilever construction. In 1971, Prestressed Concrete Handbook was published. In 1974, post-tensioning cells were distributed as welding 59%, bridges 25%, nuclear 7%, and earthwork 8%. This is the development in the prestressing. Now, if you see the history, 1938 Fire, Germany developed long line prestressing method, and in 1940 Magnell from the Belgium developed an anchoring system for post tensioning. This is related with the pre-tensioning and this is related with the post tensioning using the flat wedges. This is the, if you see the history work done in the our country India, the application of prestressed concrete diversified over the years. The first prestressed concrete bridge was built in 1948, Tamil Nadu, Rameshwaram. Now, if you see the application, brief application of the prestressed concrete, long span bridges. It is applicable for the long span bridges, which is not possible in case of RCC. Industrial shell roofs, marine structures, nuclear pressure vessels, water retaining structures, railway sleepers, transmission poles, anchoring prestressed steel bar to the dam foundation, piles and posts. This is the huge application of the prestressed concrete. Definitely at small span it is not economical, but for the long span it is the best alternative to the RCC. Now when we compare the RCC and prestressed concrete, it required lighter and slender member than RCC member. In prestressed concrete, steel is no longer required for reinforcement but provide as a means of the prestressing. It requires about one-third the quantity of the concrete and one-fourth steel as compared to RCC. See the economical aspects. In prestressed member, whole section is effective, whereas in RCC, only PU to 40% of the concrete actively resists the bending. That will be the wastage of material. In prestressed concrete member, dead load may be counterbalanced by eccentric prestressing, whereas in RCC, dead load is of great importance. Prestressed concrete member possess better resistance to shearing forces due to the effect of compressive stress due to the cable profile, which is not possible in RCC. In prestressed concrete member, use of high strength concrete and freedom from cracks contribute to improved durability under aggressive environmental conditions, which is not possible in RCC. Long span structures are possible only in prestressed concrete, whereas RCC very heavy sections are required. Therefore, it is not economical and not safe. Factory products like railway sleepers, electric poles are possible in prestressed concrete member. Prestressed concrete members are tested before use, but RCC member cannot be tested as such. Prestressed concrete structures deflect appreciably before ultimate failure, thus giving ample warning before collapse, which is not possible in RCC. Fatigue strength and prestressed concrete member gives the better resistance for the fatigue, that is the repetitive load. Multiple units are possible by centralizing the prestressing work, which reduce labor cost and gives better control to the products. Thank you. Now this is the second lecture. Thank you. Have a nice day. Stay safe at home. Thank you. Thank you very much.